I'm recording orally what I'm saying. It doesn't go too far out to you, so you can't generally hear what you're saying. So if I ask a question, you won't hear the answer, unfortunately. But you can hear me, and you'll certainly see this. Right, so the sessions that we're going to do are going to involve a drill, and we're going to look at that in a second. Okay, 10 minutes, quarter of an hour, something like that at the beginning of the session. And then my input. So I'm going to do a bit of teaching. That'll take about 35 minutes, 40 minutes. I don't want to run on too long. So the drill plus that, an hour, something like that, leaves half an hour for us to do some practice. So that means you'll get some work from the textbook, exercises to have a look at, other handouts that may come round. And then at the end, 5 minutes at the end, to review what we've been doing. So that's a sort of session plan. That is the website, the Google Sites for some maths work that I'm going to put on. That's where the answers to the exercises will be. I'm just going to start another page where I'm going to put all the lecture notes and stuff. So that's sort of where you'll go. But once you've done it, you just put it on your favourites, and it's one click and you're there. You don't need to sign into anything or log on. You just get straight to it. Okay. So if you want to just make a note of that. Okay, so drills then are going to be part of this course. Here's the first one, and there's the first question, the first drill that you're going to get. You don't need to write the question down because it's there for you to look at afterwards. This will go up on the site, so all I want to do is jot down the answer. Most of them intend to be done in your head. If you do need to do a little bit of working out on the side, that's fine, just do it, but no calculators. 10% of 48 meters. Number 2, I'm moving along reasonably quickly, so they're supposed to be done fairly quickly. Number 2, 3/4 of £8.20. Number 3, 2 times 3x. I could write it like that, 2 times 3x, 2.3x you sometimes see, 2 brackets 3x. They all mean 2 times 3x. Just jot down the answer. What's 2 times 3x? X, and at the algebraic x, the unknown. 2 times 3x. Number 5, not the answer to 1/3 of 48. That's not what I'm after here. Oh, I'll jump one. Number 3, 2x plus 3x. Number 5, oh, it seems to be jumping about the place. Number 5, so not what's 1/3 of 48. I don't want that. That's not the answer. 1/3 of 48 is the same as 48 divided by what? What's the missing number there? 1/3 of 48 is the same as 48 divided by what? Number 6, a formula that I hope you're familiar with. Anybody tell me what it is? Right, yeah. Ohm's law, somebody said over there, which is, you knew, didn't you? Voltage is current times resistance. Ohm's law, it's sometimes called. I is 12 amps, R is 24 ohms. What's B? Number 7, a half plus 3/4. Number 8, estimate the mass of a small car like a Mini, say. What's the mass? I'll leave you to decide what unit you're going to measure it in. Number 9. 3 of those are the same. One is different. Which is the odd one out? And the last one, out of the previous 9 questions, so it's out of 9, how many do you think you got right? That's a confidence question. Are you confident in your answers? Let's have a look back at these now. You're going to self-mark them, and I just want you to, at the end, just put a mark out of 9. How many you got right, and I will collect them in. And that's what we were going to do each week. Well, most weeks. This sort of stuff. And then I'll gradually introduce more questions based on the sorts of stuff we've been doing the week before and things like that. So I will ask a few people at random just to tell me what they think their answer is. Don't matter if you're wrong, it's a learning process. Josh Henwood, 10% of 48 meters, 4.8 meters. Good, thank you, Josh. How did you work that out? Yeah, put a dot in the middle. So where is the dot before you put it? Yeah. No decimal point means it's there. So if you see a number and there's no decimal point there, it's at the far right hand side, isn't it? So if I divide by 10, which is what 10% is, 10% divide by 10, I should have asked you that, Josh, but I assume that's what you were thinking, okay? Divide by 10, move the point back one place. So to get 10% of something is easy, isn't it? Okay? Which then means, of course, if I want to find 5%, that's easy. What would you do? Yeah, half 10%, work out 10%, divide by 2. Double it, etc. Okay? It's easy to find certain key percentages, isn't it? Knowing that little thing, that to find 10%, you just shift the point back one place. A useful thing to know, Josh, isn't it? A useful thing to know. I use that sort of thing all the time. VAT nowadays is 20%, so that's dead easy. Just 10%, then double it. Number 2, 3/4 of £8.20. Connor? No. Oh, bugger. Fraser. Yeah, Fraser. 3/4. £6.50. You tell me, is it £6.50? Are you confident? Yeah. I agree. What did you do to work it out, Fraser? Oh, okay. Half it. And then what did you do? Half it again to get £2.05, and then add them together. Yeah, to get £6.15. Anybody do it different way? Divide by 4 and then times by 3. Yeah. What did you do to divide by 4? Sorry, what's your name? George. What did you do to divide by 4? Yeah. So what actually literally did you do to divide that by 4? Did you do this? You did that sort of thing, half and half. Yeah. Okay, and then times it by 3. No, George? Yeah. Right, so you sort of did that, but in your head. Yeah, I see. Okay. Well, that's fine, George, but can you see that? Because that's what I wouldn't always do to get a quarter, half and half again. Is probably a bit quicker than what you're trying to do. You know, I'm not saying anything's right or wrong. Anybody else got any other ideas about that? Okay, so that's again a useful thing, and it sort of reminds us what fractions mean, doesn't it? This number at the bottom, of course, and it's worth pointing out, means how many bits have I divided into? 4 bits. George is dividing into 4 bits. That's what that's telling me to do, isn't it? The top number is telling me how many of those I've got. Is it possible to have this as a fraction? Yeah, perfectly possible. What am I dividing the whole one into? And how many have I got? Right, so I've actually got more than the whole one, haven't I, effectively? But it's still perfectly valid. It's called a top-heavy fraction. 5/4. And algebraically, we tend to use that rather than the mixed number, which would be 1/1 wouldn't it? Okay? So these things about fractions are very important, certainly when we come to algebra. And there's a whole section on fractions in the textbook and other resources on fractions. If you feel dodgy about fractions, sort it out. You know, see me and get it sorted. Because if you don't, it's going to come back to haunt you over and over again. Algebra is key to this course. Algebra is the engineer's friend, because we're often after this unknown x. So you need to know the laws of algebra. To the right of Michael, Luke, did you say 5x? Why 5x, Luke? Just add them together. What does this mean to you? Right, well, what does it mean? What is x? Sorry, Luke, what is x? Anything. Specifically, though, an unknown value, an unknown number. Not a thing. X doesn't represent a nut or a bolt, or it means a number. I just don't know what that is. What does I've told you, what does 2x mean? 2 lots of that, doesn't it? It means x plus x, doesn't it? So what does this mean? 3 lots of x, add them together, 5 lots of x. I hope that's completely obvious to all of you, but I've found over the years that the struggles people have with algebra is because you've missed the basic idea of these things. That's why I'm doing it. Okay? So, if that's obvious, good. 2 times 3x. Can you tell me your name? Sorry. Lee. 6x. Why 6x, Lee? Yeah. 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 I've got 3 lots of x. And that means I've got 2 lots of that. Okay? This is probably the best way to write it. 2 lots of 3x. Look at it for a second. Brackets. This idea of bid maths, you do brackets first. So that's saying I've got 3x, and then I've got 2 lots of that 3x is 6x. Sometimes you see that, 2 lots of 3x. Little dot is 6x. Less common. That we don't tend to use. Why not? Yeah, that x, that could be misinterpreted as an x, couldn't it? X and x. So don't use the times symbol with algebra. Okay. Third of 48 is 48 divided by 3. Certainly is. Thank you. Sorry, your name? Josh. I will eventually get to know you. Yeah. Hopefully obvious again, but as far as algebra is concerned, that means that this is true. So have a look at this. Look at that. That's that written algebraically, look. A third of x is equivalent to, that's what that means, equivalent to, the same as x divided by 3. So that means x divided by 3. X over 3 means x divided by 3. Have a look at it. Is that obvious to you? If not, it's really important, again, because you might see within a formula this, look. Is that the same as this? Yeah. Because of this, look. Divide by 2 is the same as a half. They are equivalent. And that's not immediately obvious to some people because of the confusion around this. So look at it, okay? All these little things build up to become a major problem, these little things, if you don't get your head around them. Harry, what do you reckon? 288? 288. What, Harry? Volts, yeah. Don't forget the unit when you're working something out. How did you work that out? And what did you do to do that? Did you just know it? Right. And did the multiplication. So could you have done it in your head? What would you have done to do it in your head? Anybody? Times by 10, Harry? 24 times 10, 240, times by 2, 48, add them together. Yeah, little tricks. That's what I was saying earlier, remember? If you reach your calculator for these sorts of things and you're employed by somebody, he's going to doubt your mathematical ability a bit. It's all down to giving people confidence and your self-confidence. The answer is given away by Connor here at the beginning when you said what is this and you said V equals voltage current times resistance. I didn't mean that to be said because of course it's implied in the formula. If there's no let symbol between I and R, that means multiply them together. Yeah, no symbol means multiply. Back to this, look, we take that as read. If there is no symbol, it means multiply. Because we don't use the multiplication symbol, if there is no symbol, it means multiply. Okay. Half plus 3/4. Right, you're not sure. Right, okay. Why 5/5? Right. Fractions you need to get your head around then. Okay, let's look at this. A half plus 3/4. Anybody? Yeah. No? Not sure? Not 2/3. Yeah. 1 1/4, which remember is the equivalent to 5/4. 5/4. That's a half, isn't it? Sorry, what's your name? Rob. A half made up of 2/4 plus 3/4. Makes it, you see what I'm trying to draw there? Not very well. 1, 2, 3, 4, 5/4. And that's what I've written here. 5/4, which is 1 whole 1 1/4. What's implied here is that you understand that that's 2/4 plus 3/4. And when you add them together, you get 5/4. It's very important, Rob, because you admitted to it straight away, which is good, and I'm sure you're not the only one, I'll absolutely guarantee that you get your head around these fraction things, okay? You need to see me about that. You've got to, you know, start the ball rolling. I can point you at different things, I can show you in the exercise, we can go over some stuff, but if you don't do anything about it, it's going to be a problem all the way through, okay? Fractions, yeah, because they come into algebra. And you combine fractions with algebra, and if you're not sure of the fractions, then it's going to be even harder. Did you estimate that, Rob? What did you get? 600 kilograms. Anybody else get anything different? A ton. Oops. Any others? 1.5. Who's speaking? Sorry, I missed it. 1.5 tons. Oops. Done it again. Any others? 1.25. Hedging your bets. Well, the new Mini is heavier than the old Mini. I looked it up. The new Mini is around about a ton. The old Mini is about 700 or 800 kilograms. So not a bad estimate. Any of those really. Is it a useful thing in engineering to be able to estimate things? Have an idea? Yeah, it is. Okay. Right order of magnitude. By that I mean not 100 kilograms, not 10,000 kilograms, but round about 1,000 kilograms. By the way, what's a ton in kilograms? Yeah. So 1,000 kilograms, 1,500 kilograms. So a bit heavy, you know, a bit over. Around about the ton mark is nearer. Number 9. I got myself tangled up again. Number 9. Not an easy one, this one. 2 times a third. Think of the questions you've just been doing. What's that the same as? 2 times a third is the same as 2 divided by, which is that one, isn't it? 2 divided by 3 is the same as 2 over 3. So it must be B. Must be B. How should I have written B? Yeah, it should be how many 3's are there in 2? Okay, down to fractions again. Just look at this, people, please. Okay, 2 divided by 3. 2 divided by 3. Is the answer going to be less than 1 or more than 1? Less than 1. It's 2/3, which is less than 1. 2 divided by 3 is the same as that. Look, they mean the same thing. If I want to work out what 2 divided by 3 is, I work out how many 3's are there in 2. Bottom into top, not top into bottom. Right, so add them up, give yourself a mark out of 9, and then I can compare that with that. So you don't add that to your final score, that's just a So it's out of 9. Add them up, please. Right, now I want to just do some work on formulae, which is the last thing. The last aim today was to sort of introduce the idea of using formulae. So now you're going to need your calculators. If you want to get your calculator out so it's ready to go. If you don't own a calculator, you need one. If you own a calculator, bring it along. It's a right pain in the backside when people keep borrowing your calculator all the time, so don't impose that on your friends. For now, yes, but do purchase one because they're not that convenient, honestly, okay, Harry? So get yourself one. They're reasonable. They're only about 5 or 6 quid in Tesco's. You know, these nowadays they're really cheap. If you're going to buy one, get the solar ones because then you don't have to worry about batteries. Okay. I've written on the board here some formulae. Have a look at them. If you're into cooking, a bit like a recipe really. Anybody recognize any of those formulae? George, Ohm's law, right, we've seen that one already. So what's it telling us to do, this recipe? Yep. Yes. To get the voltage, I multiply the current by the resistance. This formula is one where the voltage is the subject of the formula. It's set up to read voltage equals something, so it's designed to find the voltage. If I want to find the current or the resistance in this formula, I have to rearrange it. Current and resistance are not the subject, but I can make them the subject by rearranging it. And we'll have to do that. Okay, so more on that later. Any other formulae? Yeah. Yeah, total resistance, so RT for total resistance. Anything else about this? Unlucky, it's the other one. Parallel, yeah. Okay. For 2 resistors, R1 and R2, 2 resistors in parallel, that's how we'd find the total resistance. Sorry? No, you'd think so, wouldn't you? But it's not, because it's 1 over RT. In fact, that 2, this top right one, is also for 2 resistors in parallel. 1 over the total resistance is 1 over R1 plus 1 over R2. So in fact, that formula and that formula are the same. And some of you may already feel sort of confident with your algebra that you could rearrange this top right formula and get that one. And you can do that. Michael. This one? Yeah, so this one here, so that we can see it when you're looking at the video, that one. Yeah, so what's the recipe? What have we got to do? Power. Yeah, to get the power, we multiply the voltage by the current. Power in watts, yes, well done. And again, this is set up, this formula, to find the power. Power is the subject of the formula. So what about this one and this one then? Yeah, sorry. Yeah, voltage. Velocity is displacement over time. This bottom right one, well done. S is the common symbol for displacement, which is a vector equivalent of distance, as you all know eventually if you don't already. So V for velocity, sometimes people call it speed, but speed is the scalar quantity. Velocity is distance or displacement over time. Well done, yeah. So this one that we've not talked about yet is to find pressure. And the recipe for that one is I need 3 things to find the pressure. I need to know what rho is. Yeah, rho is a Greek symbol which represents density. So this is the Greek symbol rho. we will be talking about this again, so don't worry about it too much. G is gravity, and H is the height or depth, so it's pressure in the liquid or the atmosphere. So if I know the density of the liquid or the atmosphere, the air that I'm in, and I know gravity and I know the depth or the height, I can find the pressure. What would I do to find the pressure with that? What was his recipe saying to do? Multiply them together. No symbol, multiply. So there we have some formulae. What I want you to do is to, given some values, calculate the pressure. Right. So, Lewis, yeah? Solution? Sorry, Lewis, can't hear. Say it again. Lewis, sorry, I'm asking Lewis. Yeah, yeah, yeah. Are you both Lewis? Yeah. Oh, sorry, right, this Lewis.
3.6 times 13,000
Yeah,
times 9.81
yeah. Equals, got an answer? Have you not done it?
yeah, just
Right, okay.
482,906.
Did you put a unit at the end? Okay. Any other answers? Any other units? Yeah. The unit's wrong, unfortunately, Lewis, but it's at least you tried to put one in, which is the main thing. Newtons per meter squared, yeah. Newtons per meter squared. And there's a common name for that. Begins in P. Pascals, which you will have heard of, I'm sure. Okay. Right, now, if you'd have been asked to do this at work, you'd have come up with an answer like that, fine. You'd have written the units correctly, that's good. However, I would have been very surprised at that number if you'd have given that to me as an answer. Any idea why? Too long, Rob, yes. So what would you do? Round it, good, okay. And to ask yourself how to round it, you would look at what you put in, look. So, what do you reckon, Rob? What, these? No, you don't round up the numbers you put in, because hopefully somebody's measured G to that accuracy, 9.81. In fact, you'll have looked that up in a table. 9.81 is common. In fact, we know it to more accuracy than that. The density of mercury we know to more accuracy, and that's what this is, the density of mercury. But this is written to 3 significant figures. Michael. Yeah, something like that. You're dead right, Michael. Yeah, you're trying around it, something like that. But to decide on the accuracy, we look at these figures. That's written to 3 significant figures. SF. That means there are 3 measured numbers there, look. 9, 8 and 1 have been measured. 3 significant figures. How many significant figures here? 3. 3 significant figures. How many significant figures here? 3. Not 5. Zeros are not significant. They're just there to make sure the 1, the 3 and 6, which are significant, are in the right columns. In other words, you need the zeros there to hold the place. Okay? How many significant figures in the answer? 3. Okay? The rule of thumb is your answer, and if you think of it about this, it's common sense, your answer cannot be more accurate than the least accurate number you put in to your calculator. I'll say that again. The rule of thumb is the accuracy of your answer cannot be higher than the least accurate number you put in. So in this case, they're all 3 significant figures, so my answer would be to 3 significant figures. Sometimes you can go one more, so maybe 4, but 3 generally the same. So I'd look at this. First significant figure, second significant figure, third, 3 significant figures. Then I look at the next one and I ignore all the rest. They're unimportant, just the next one. If that's 5 or more, I'll round that up to a 3. If it's less than 5, I leave it as a 2. So this would equal 483, but I can't finish there because I've got to make sure it's in the right column. So 483,000 newtons per square meter. And then I would say I've rounded it by writing that to 3 significant figures. So that's okay, Lewis, to write that, but then you would round it. Okay? And it's not good practice not to round it. So if you're in any doubt as to how many decimal points or how many significant figures to put off your calculator when you're writing an answer down, that's the rule to remember. Write as many down as you like initially, but then round it. So this equals 483,000 pascals, or newtons per square meter, to 3 significant figures. They're interchangeable, those units. What else might I do? And Michael, you were talking about this, so what would you do now? And do what? Yep. 483 times 10 to the 3 pascals, to 3 significant figures. That's using what's called engineering notation, which must go in 3s, 3, 6, 9, okay? And by using engineering notation, that means we can do one more thing. Instead of writing 483 times 10 to the 3, I can write, yes, 483 kilopascals. Well done. To 3 significant figures. And if I were to write that as my final answer to my boss at work, if he'd asked me to calculate that pressure, he'd be, that's good, you know. This guy knows what he's doing. He's competent. He's not giving me all these horrendous decimal points and numbers which mean nothing. It's just a calculator calculating, you know. The calculator doesn't know anything about accuracy. You have to put that bit in. Okay. Comments, questions? Right, just quickly 5 minutes and we'll finish early. I said we would. Okay. Anything about the aims of today to come out? So the first aim was to do with general competence in mathematics. Is general mathematics important in engineering? Yeah. Evidently, yeah, because I've said so. Yeah. But has anything that you've done today helped you think that that might be true? Anything? Have you improved your competence in mathematics today? Anything you've learnt from that drill that you'd like to state? I'll put it here. Refreshed? Did somebody say yeah? Rob? I've got your number now on fractions, so I'll be keeping an eye on that. Good. Okay, but you need to move on with it, okay? Fractions, important. What about using formulae? Anything to take away from today that you've learnt? Please don't pack up until I've finished. Let me just do this review and then you can tidy up. Anything you've learnt today, what we've just been doing on formulae, that's worth making a note of? Okay, so the accuracy. Not more than. Finish the sentence. Finish the sentence. Accuracy is not more than. Yeah. Or least. Go on, Rob. Least. Yeah. What word would you use? Least accurate value. Good word. That you've entered into your calculation. Okay. That's a good rule to remember. If you're asking yourself on the calculator, I've got all these decimal points and numbers on the calculator, how many are we going to write down? Bear in mind at the end of the day, you can't be more accurate than the least accurate number you put in. Okay.